So we're going to talk about the C and the H and Tech method. So we talked about the T and E temperature and evaporator. So we're going to pick it up from a couple, well, it's almost been a month now. But we're going to talk about compressor and heat loss and heat gain or heat transfer and how we measure those things. So the C stands for compressor and condenser or the condensing unit. So once you've checked your temperature, you've gone down to the case or the space or the, whatever piece of equipment you're working on, and you've checked the evaporator conditions, you're going to move on to the compressor and condensing unit. So compressor operation, after checking the temp and inspecting the evaporator, you will move to the compressor and condenser. When inspecting the compressor, first of all, just use your senses. So, touch the suction line. Be careful with the discharge line. I always tell guys, try not to, if you touch it, usually, lick your fingers and tap it with your fingers. So just make sure that you've got good heat there. If it's cold or cool, you might have a flooding issue. You might be out of refrigerant. There could be a couple things. You might have bad valves. So just make sure that, when you guys are checking those things, you can touch the discharge line will tell you things. Another thing that you can touch on the compressor if you're dealing with a semi-hermetic compressor is touch that oil pump. Oil pump should be warm, so to the touch. So cold oil pumps are bad. So cold oil pumps usually tell us that there's liquid in the body of the compressor. So we don't want to have a cold oil pump on a running compressor. So
where's that thing sit at?
The oil pump's right on the front of a semi-hermetic compressor. So if you're dealing with a Copeland, it's usually right there on the front. If you'll know a pump because you'll have your gauge up ports on the pump. So that's another quick check. You can check the oil in the compressor. If you don't have a sight glass, usually if you have a sight glass and you touch the pump, it'll tell you if that's oil or if that's liquid inside the sight glass. So you always want to touch the oil pump because it'll tell you what exactly is in that crankcase. So here, if you can hear the compressor condenser fan running, does it sound okay? So do you know how it should sound? So these are, again, we're just using our senses. So C, is there oil in the sight glass? Is the paint or identification discolored from excessive heat? So what we're talking about there, and is there flood black present? So, we used to be able to come up on the can compressors or the hermetic compressors, and you could see discoloration of the white tag on a Copeland. It'd be like brown. So that compressor's gotten fairly hot. So, or the paint on the body of the compressor on the top of the head starts to discolor, that compressor's gotten fairly hot. So that'll tell you some things too on an overheating situation. So another thing too is if you guys are working on a rack or a multiple compressor or a staged compressor unit, you can always touch the top of the heads of the compressor and just know if one's been running or not been running, right? So if they're running, a quick check to tell you if the compressors have been running is just touch the top of the heads when you're walking down to know if they're coming on or not. So a lot of times guys forget to tag a compressor out or lock it out. So when it's bad, there'll be no indication on the front. So usually just out of habit, I usually walk the rack line and touch the top of the head of the compressor just to see which ones are running and not running. It's just a quick check down. And then on my way back down the compressors, I'll touch the front of the oil pump. So it's just a quick 2-second check. Hey, I'm running. Hey, it's oil, not liquid in the system. So we're doing okay. And then I go to the back of the rack and start looking at the pipes coming in to see if we have any flood back issues. So just a quick touch and sight check that I do almost every time. It's almost the first thing I do anytime I walk into a machine room. So do you have power to your contactors, start components? So, if you've done your checks and your temperature's warm and you know that your thermostat's calling and you go up to your condensing unit and it's not running, so and you have a call for cooling, like your solenoid's open downstairs or your thermostat's directly wired up to the compressor condensing unit, and you have the circuit's closed and you're calling for cooling, right? But for some reason your compressor's not on. Now we're going to start checking your different electrical components. So are the safety controls tripped? Does everybody know how to test a safety control? Have you guys ever done that? Okay. What you're going to do is you're going to take a screwdriver, you're going to pull the front cover off that. On that low pressure control, some guys will take a little control screwdriver and shove it underneath the bellows on that spring switch to check if it's on. Or you can grab the back of the hammer where the spring is and the little hammer mechanism, and you can push on it and it'll actually close the low pressure control. Okay. You can check, and so obviously if it's off on a low pressure situation, either the solenoid's not opening, for some reason you're not gaining pressure at the point of where that pressure control is. So it's either out of refrigerant, it could be the solenoid's not opening and allowing refrigerant to flow through. It could be a restriction in the TXV if it's short cycling on and off on that low pressure control. So that's how you're going to test that. Anytime you're testing across those leads of any of these types of controllers, when you pull that cover off, you're going to have 2 or 3 wires going into it depending on the style. So you're going to need to understand most of them's two lead. So all you're going to need to do is go across the leads with your meter. As you go across the leads with your meter, you're going to get a value there or not value there. If I see no value across that meter, what's the second thing I'm going to do?
Check the power.
I'm going to keep one on that lug, and I'm going to go to ground. See if there's current voltage present. So, and if there's current voltage present and I go across the lugs, then I know that switch is closed. Okay. Does that make sense? If I go across the leads and I see value there, then it's going to tell me that the switch is open for whatever reason. So, and if you're dealing with this dual pressure control, this type of switch where you have the high side and the low side through one controller, it could be open on either side. So you could have a high pressure, or you could have a low pressure. Like I said, you'll know you can eliminate the low pressure just by grabbing that hammer, shoving a screwdriver under there, and engaging the low pressure control. Then you know it was on the low pressure side. If you do that and it's still, the switch is still open, then you have a head pressure control issue. Make sense?
Okay.
So
Hey, Jim.
yeah.
The Zoom is still on slide 1, just so you know. I'm not sure if it's changing.
Okay. Hold on one second. Is that better?
Yeah, I'm sorry to interrupt.
No, I appreciate it. I didn't know you guys weren't seeing that. So back to, let me see if I can. This is a low pressure control trip. Okay. This is a dual pressure control. That's a head pressure control with a manual reset. So you're going to actually have to push the button. Okay. We'll talk about button pushers here shortly, how I feel about that. So, and then, you know, you may have a fan cycling control on your condenser fan. So all those types of switches look the same. So you could have just a low you could have 2 of these boxes. There's also an oil fill control that has the pen oil fill control, the old mechanical ones. It'll have 2 cap tubes, one going into the crankcase and one going into the oil pump, looking for the differential of pressure. So the first thing you need to identify is what controls do you have on your compressor, safety controls, and then you need to start troubleshooting through those controls to see if you have an open switch that's breaking the power to your compressor contactor. Okay, that's how we're troubleshooting that. So all of these safety controls are there to protect that compressor. So oil fill is there to protect the compressor, head pressure is there to protect the compressor, low pressure is there to protect the compressor. So that's why those safeties are in play. So just identify those. You may not have this type of switch. You may have more of like an encapsulated switch, but most compressors have safety switches in play. So yeah, low pressure, head pressure. And then when you're dealing in low ambient conditions, you're going to deal with like a motor master or a fan cycling control or a head master. Okay. So is the head pressure control tripped? Is the dual pressure control tripped? So all this one right here is these 2 controllers into one. And because there's not a reset on here, it's going to automatically reset. Meaning it's going to hit head pressure. It's going to wait for the head pressure to drop, and it's going to try to start it again. And it's going to do that and cycle and cycle and cycle. So until you fix the condition of why it's tripping off on head pressure. Okay. Here's a couple other controls. A lot of these you'll see on bigger systems, bigger single systems, like your Centronic, that's a Copeland control. So that's how they do their oil fill control. So this is where I'm going to talk about button pushing. If you guys come up on an oil fill control situation and you hit the red button and call it a day, you're coming back. Or somebody's coming back behind you, and when they find out that you hit the red button and just walked away, they're not going to be too happy with you. Okay, that controller, these 2, this is an old style of a Centronic. This is a newer style. Now they have Core Sense, which is an even newer style of controller that actually senses a lot more on the compressor. But if you guys come up on any of these are all oil fill controls. So this is an OMB module or a Trax oil, depending on the technician you talk to. They're going to call it two different things. OMB is the model number. Trax oil is what it used to be called, but it's the same type of controller. This is a mechanical one. This is the one I was talking about. Okay, it looks for a differential across the crankcase and the pump. So the actual low pressure in the compressor and make sure the pump. So to make sure that you have oil pressure there in the pump. If you drop below a certain threshold, like I think, you know, it's 12 PSI or 8 PSI, depending on the compressor, it's going to trip the compressor out. It's going to take it right out of and say, you don't have enough oil pressure there to continue to lubricate the compressor. We're going to shut it down until we fix whatever conditions causing us not to have lubrication in the compressor so we don't damage the inside of the compressor. Okay. So that's what all of these different controllers, you might run into any one of them. You need to understand that if you're tripped off on oil probably, in my opinion, is the one thing that kicks everybody's butt. When you guys are dealing with oil issues, it's usually you got to go through a few steps. A lot of times some steps are missed or some steps don't want to be taken because, you know, digging into an oil system is usually a lot of work and a lot of time to kind of diagnose the issue, and it can come and go. It's sporadic. You can hit that red button and stand there for 2 hours and nothing happens, right? Then you go home at 2 a.m, they call you back out because the store's warming up. So if you guys run into an oil fail situation, I would definitely get your manager or your senior tech, lead tech on the phone and run through all of the things that it could be and make sure you dot the I's and cross the T's when you're going through that troubleshooting method, because oil fail situations always kick the technician's butts. Okay. So what should you do before you reset? Let's talk about what you should do before and what you do after. So whatever piece of equipment you are working on, you have to identify safeties, use your meter to check them. So I don't want you guys to use the reset button as your check. What I want you to do is pull the covers off the controllers and use your meter to see what's open first. And then it's going to tell you what to do before you hit the magic button. Okay. Before you hit the magic button on an oil fail, at that point, I want you to gauge up to the compressor and the oil pump, and I want you to check your net oil pressure. So if you're talking to me on the phone or some of your lead technicians, and I'm talking to you about oil, I say, what's your net? I want you to look at what it's the difference in the pressure between your crankcase pressure and your oil pump pressure. So it needs to be about 35 to 55 for a Copeland is where it's healthy. Okay. So if you're looking at that pump pressure, I want to hear 35 to 55, somewhere in that range. And then I know our pump's working good, because that's the ranges of the sizes of compressors. So I want to hear, most of the time it's 35 for what we deal with on the rack, the discs and stuff, the inlines. So as long as we're sitting around 35 oil net oil pressure. So that's the oil pressure minus the suction pressure. Your suction pressure is going to be lower. Your oil pressure is going to be higher. So you're going to take what that oil pressure is. So if you had like a 75-pound oil pump pressure, I would want to see 45-pound suction pressure or lower. So that gives me that 35, or I'm sorry, 70. If I had a 75, I would want a 40 or lower. So I'd get that 35 net. Make sense? So if you call me on the phone and I say, what's your net? I want you to be gauged up to the oil pump and the crankcase, the suction line. You can do the king valve on the backside. That's the crankcase. That's the suction pressure. And tell me what the difference in the pressures is. Okay. Condensers after. So, you know, I do a whole class on oil controls and all the different kinds and how you diagnose and how you troubleshoot. So that's about as deep as I'm going to go today with that. So we'll cover more on oil controls. So condensers, after inspecting the compressor, and the condenser needs to be inspected, the type of condenser you will be dealing with will determine the type of inspection required. So, you know, this is an.
Hey, Jim.
Yeah.
Would it be good to maybe have the techs also take a look inside the sight glass on that compressor at the oil? Got to kind of get identification there for that as well.
Well, yeah, obviously, like I said, when you guys get in, if you guys haven't come into an oil fail, the best thing that I'm going to tell you is get your technician on the phone, because we're going to want to know what controller you're dealing with. We're going to want to know if a sight glass is present. We're going to know what the oil color looks like. Like I said, I could spend a whole 2 hours talking about oil, but what I will tell you just for this class, because I've got a lot to cover about C&E, is, you know, obviously look to see if there's oil present. Look at the color of it. It should be like a nice golden brown. Some of the synthetics are almost clear. So the problem with the synthetics being clear is liquid's clear too, liquid refrigerant. So when you hit that magic button, if you have pressure there and all of a sudden you see the oil start to foam really bad, and you hear the compressor barrel down, you better have your hand on the control switch or the breaker to shut that thing off because you're pumping liquid. Okay, that's why I said you need to be ready to go. Don't ever just hit the red button. I watched people silhouette themselves on a sheetrock wall because they hit the magic red button, and it barrels down with liquid, blows the head gasket out, and shoots oil all over them to the point where you can see the oil silhouette of them doing one of these as they're trying to get away. So you want to make sure before you hit the button that you are ready to go. So that's what I'm saying. When you guys are doing oil issues, it's the couple times that I have watched the compressor hydraulic and blow the head gasket right out of it. And it takes a second to you got to hold your breath and hurry and isolate that compressor. So it's a little bit nerve wracking. So it's a big loud, so you don't want it to happen. So I want to make sure that you guys are ready to go and that you've talked to your senior technician before you go to hit the magic red button on an oil fill control. Okay. Condensers. So this is an air-cooled condenser. This is a shell and tube condenser. This is an evaporative condenser. So we see towers down in the Phoenix, Vegas, hotter areas. We'll see a lot of towers with building where they're confined spaces. Air-cooled condensers usually take a little bit bigger footprint as far as area. So, and you get a little bit more efficient cooling out of a water-cooled. The only thing about water-cooled is like you got to do some treatment in certain areas, or you turn that, what we call the copper bundle, turns into a rock really quick if it's not treated correctly.
I've seen those compressors, the big one.
This condenser?
Yeah, over in Beaver.
Yeah. Yep. Yeah, you're going to see, these are extremely efficient. The only problem is like if you're dealing in a region that has, water restrictions or water, you're using water for evaporation here. So to transfer the heat as you're condensing. So, we're going to see those a lot in the South. So, and even in these air cools, if you're dealing with like an adiabatic condenser, you're going to see air cooled condensers now with wet pads as a pre-cooler. So like up at Trader Joe's, have you guys seen the one at Trader Joe's in Orem? So that's a Trillium condenser. That's actually an air cooled condenser with a wet pad pre-cooler on it. So they call that an adiabatic gas cooler because you're using CO2 on it. But we have Costco's out in Orem or in Colorado that have them. So you might see what looks like, because these have used pads, use a scrate on the top. You might have an air cooled condenser that looks kind of like a water cooled condenser, but it's an air cooled condenser with pre-cooler pads. Okay. So when you're checking that, you just want to make sure that you identify which one you're working on and then how to troubleshoot that. It's going to be a little bit different depending on, and again, if you guys have questions, this is where as you're getting into more and more of this type of bigger equipment, engage your lead technician or your service manager as you're walking through those steps. Fan motors, belts, and cleanliness. When inspecting a condenser, check the motors. So when you guys are doing your PM work, you should be checking the motors, right? You should be bumping the contactors and staging them. So what are you checking for when you stage your motors?
Temperature for the.
You want them to crank on, right?
Yeah.
Are you guys looking at the balance in the motor? You guys want to make you want to make sure your blades are balanced, because if you're balancing the blade pretty good, you're going to take the bearings out in the motor. So you want to stage that and check that. So you're going to check the belts and bearings. So you guys should be greasing the bearings. So just a couple pumps. I watched guys, let's talk about bearings. I watched guys grease bearings until they see the grease oozing out of the pillow block bearing. That's not a correct way to grease the bearing. Now you've just made the bearing less efficient than it was. So, I would say rule of thumb is just a couple. Once you know that the grease is hit, if you're dealing with tubes that go to the bearings, like on some of the older condensers, you're going to have to push enough grease through that tube to get to the bearings. Just make sure that you've filled the tube and that you get at least 2 pumps of grease into that bearing. That's it. You just want to grease the bearing long enough that you're doing it every, 6 months or annually, depending. So you don't want to pump that bearing so full that you see grease oozing out of the top of the bearing. That is the wrong way. So if you see a bearing that's scattered, a pillow block bearing on a big shaft where you're using a belt drive motor, and you look at the bearing and you see that there's been residual grease oozing out of that, it's because somebody pumped it way too full. Yeah, you don't want to overfill it. there's a right way and a wrong way to do it, and make sure that we're not pumping until, if you're pumping until grease comes out, then you just cause that bearing to go under more stress than it should. Okay. What does it mean to be properly greased? So, and the belts, let's talk about belts, because I've seen a lot of this out in the field. Belts, like what we should be seeing on trains, Lennox carriers, is cogged belts, not straight V belts. If you see a V belt, make sure you suggest a cog belt. So a cog belt for ACs, because of the torque, you want to make sure you're using the cog belt. If you do have a belt and it's glazed, it's getting too hot. So the rubber's heating up as it's going around. There's friction. Heat. It's going to first glaze, then it's going to crack, then it's going to break up into pieces because it's rubber.
What's a V-belt? Is that the one with the?
Yeah, a V belt's just, yeah, it looks like a V. So it's not like a full V, but it's called a V. So V belts cover cog belts, A belts, B belts. You know, any of the belts we're using are V belts, because if you look at them the long way, they kind of are in the shape of a V. So the thing about it is if you guys, when you roll a belt off, an old belt that's glazed, please inspect the sheaves. Okay, make sure that you're looking at the sheaves on the equipment. Make sure that it's not U'd. Make sure that because it matters the contact on that belt. That thing's running an immense amount of RPMs, so you want a nice, good contact point on that sheave. So if they're worn out because they've heated up, then it's just going to wear out the next belt within a couple of days. So anytime you guys roll the belt, you want to check that contact point. Make sure that sheave is nice and V'd as well, and then it's adjusted properly. The alignment should be straight. So the sheave center, the sheave surface should be a nice V shape. So if it's U'd out, we call it U'd out, where it's worn out because it's been resting to one side or the other and it's worn away on that metal with friction, and it's time to change that sheave. Okay, so we need to make those suggestions when we're finding that. Inspect coil thoroughly with a flashlight to ensure the coil is clean. So I can't tell you how many times guys walk up and say, yep, it's good. Like, you got to shine through the coil, because a lot of times they'll brush the front and it'll be impacted with dirt about 2 or 3 runs back. And that coil could be 3 to 5 runs deep, depending on the type of equipment, and even more on supermarket condensers. Okay. Proper condensing. So when you check for proper condensing, what are some of the ways you check? What's the first thing we can do to check proper condensing? It's an easy one. Touch the liquid line, right? Liquid line will tell us it should be a little bit warmer than ambient temp. Okay, a little bit warmer, not hot. So if it's the second thing you can do without pulling out a tool, look at the sight glass. Okay, while you're touching it, is it clear? If you're touching it and it's cool and it's clear, then you're fine. If you're touching it and it's cool and it's bubbling, you might be a little bit low. Okay, if you're touching it and it's cool, or you're touching it and it's hot, and it's clear, then you're about to, it's time to clean it. So wash it again. So, or check your rotation, or check to make sure your belts aren't slipping. So if you touch it and it's hot and it's bubbling, so then you're not condensing properly. Make sense? Mm-hmm. So that's the easiest thing. Just look at your sight glass, touch your liquid line, or touch your liquid drain leg. So if you guys are dealing with small systems and you run your finger down the return bends, that's how you can properly tell on a cap tube system or stuff if you're properly charging condensing. So 2/3, 1/3, right? 2/3 hot, 1/3 condensed. A little bit cool, a little bit warmer than room temperature. So that's where what you're feeling there is you're feeling it gas, condensed to liquid, subcooled. Get it? So you're desuperheating, now you're subcooling. So the difference between desuperheating and subcooling is when you're desuperheating, you're taking heat off of the gas, okay? As soon as you turn to a liquid, now you're subcooling liquid. That's the difference in those terms, is the state of the refrigerant.
Where are you checking that again?
The return bends of the condenser. So if you were dealing with a small condensing unit and you see all those return bends going through the condenser, start at where the discharge goes in. It should be hot, 2/3 up, and then as soon as at the very top where the drain leg comes out, it should be a little bit warmer than room temperature. It should be quite noticeably cooler to the touch. Okay. That's U-bends. Yep. Return bends, U-bends. So proper condensing, when checking for proper condensing. So we just talked about this: feel, hear, smell. So I've been in condensers. I've been in machine rooms actually where I know the condenser's not running on the roof because I can smell the dirt burning. Silly as that sounds, I can smell the dirt. Yeah, getting hot. Does that make sense? You'll know what I'm talking about. And some guys probably are laughing at this, but you'll know what I'm talking about when you come up on a rack or a system overheating. You can smell.
Yeah.
You can smell the dirt, kind of like a light burning smell. It doesn't smell good. So, what is flash gas? So we just talked about this. What causes flash gas? How do we know when flash gas is occurring in the high side circuit? So easiest way to tell what flash gas is like touch the liquid line. Okay. So flash gas is non-condensing. So if for whatever reason you're not condensing through the condenser, could be an overcharge situation. Somebody charged it in the middle of summer. They put too much gas in it. So started to throttle back and it's too impacted with gas. It could be, it's plugged up. Could be a fan motor's slowing down. It could be a lot of things, but for whatever reason, flash gas is when it goes through your heat cycle, that condenser is supposed to not only turn that, reject the heat off of that gas, but then it's supposed to turn that gas into a liquid, right? And then it's supposed to subcool the liquid to the tune of 10 to 12 degrees, or I'm sorry, 12 to 15 degrees. So when you're subcooling, that's where you're taking extra heat on. So any heat pickup it gets between there and the TXV doesn't boil back off into a vapor, because what do you want going to a TXV? Solid column of liquid, not just some liquid. So the more liquid you send there, the more efficient that expansion valve is. Okay. If you don't condense fully, then you're going to get less heat pickup because there's still heat in that refrigerant from the last time it went through the cycle. Okay. Heat load, using the H to finish the troubleshooting. Okay. Up until this point, I have only used a meter and my senses. Okay. We have not pulled out gauges until this point. This is the point where, if necessary, this is where we pull out some temperature clamps or K thermometers and our gauges. Okay. So what I will tell you guys about gauges is there is specific types of gauges that you need to use for specific types of equipment. Do not use 6-foot hose gauges on a fractional charge system. You're going to be there a long time now because you just messed with the charge. So critical charge systems, do not use supermarket gauges on. Supermarkets hold 900 pounds, anywhere from 600 to 1,100 pounds of refrigerant per rack. So you got a little bit of fudge factor there for those 6-foot hoses. So ice machines and stuff, you do not. So make sure you have a set of stubbies. Make sure you have a set of gauges, right? Charging hoses. Okay, if anybody has any questions on that, get with your service manager or me afterwards, and I'll send you some pictures of what I'm talking about. So when using the H, when you're applying the H, you need to use temperature clamps, or I would prefer clamps. So I've seen guys try to tape K thermometers to the pipe. You're not going to get a true reading. Spend a little bit of money and make an investment in clamps. A PT chart. So we're going to go through the old school way of actually having to use a PT chart and convert. So refrigeration gauges and knowledge of how to properly check superheat and subcooling. So measuring subcooling. So where are we going to look at subcooling, guys? But what type of systems am I going to actually go after subcooling instead of superheat? HVAC, yeah. When you're dealing with high temp, most high temp manufacturers are going to tell you to check the subcooling, not so much the superheat. Okay. So you need to understand how to do both because you work on both. So get the refrigerant saturated pressure temperature, take the pressure reading of the liquid line leaving the condenser. Refrigerant saturation temperature is the pressure temperature. Temperature is the pressure temperature when the refrigerant is turning from a high pressure vapor into a high pressure liquid, giving up heat at saturation pressure temperature. Both liquid and vapor are at the same temperature. Okay. That's wrong. They're at the same pressure. Okay. Not temperature. So when you're condensing, that there will be a temperature change, but your pressures won't change much. So when you're at the condenser, whether you're at inlet or outlet, your pressure's not going to change much. Your temperature will change. The sensible heat will change. So you'll be able to feel that conversion from gas to liquid. So convert pressure to temperature with a PT chart. Take temperature reading at the leaving liquid liquid line of the condenser. Compare both at saturated temperature and leaving liquid line temperatures. Subtracting one from the other difference, the amount of the refrigerant has cooled past the saturation temperature. So what you guys are going to do is you're going to look for that drain leg coming out of the condenser. The drain leg is where it's condensed to liquid, right? Because we're checking subcooling, we have to be checking a liquid, correct? So that's how you remind yourself. If I'm looking at subcooling, I want to look at how much cooling I've cooled past the point of saturation, past the point that it turned to a liquid. Okay, so that's what I'm looking for. So because what that's telling me is how much heat pickup potential I have at the evaporator, and that's how ACs are working. So if they know if they have 10 to 12 subcooling, that they're going to get solid liquid to the TXV, and if they get solid liquid to the TXV, they should get X amount of pickup of heat through the evaporator and then transferred back out to the condenser. Make sense? So it's a mathematical way of checking, a very specific measurement way of checking to make sure that we have the right amount of heat pickup there potential at the condenser. So now if you're dealing with medium and low temp refrigeration, superheat all day long. We're going to check superheat. Subcooling does matter. So when you get into the big systems, your valves are sized for a certain amount of mechanical subcooling, and we'll talk about that a little bit, but what that is really telling us, if we can get, that because we're running such long pipe runs, liquid line runs, that's why mechanical subcooling matters, because all that copper is that you're piping 200 feet out to the case, right, has potential heat pickup. Even with it insulated, it's still going to pick up a little bit of heat. It's going to pick up less if it's insulated. That's why we insulate both lines in refrigeration supermarkets, is because there's heat pickup going on, and we want to pick up as least amount of heat as possible to ensure that we're getting subcooled liquid at the TXV. Okay. So gas pressure reading of the suction line leaving the evaporator to get refrigerant saturation pressure temperature. Refrigerant saturation temperature is the pressure temperature when the refrigerant is turning from a low pressure liquid to a low pressure vapor, absorbing heat. So at saturation pressure temperature, at both liquid and vapor are at the same temperature. Okay. So when you guys are doing your superheat calculations, there's always you need to come off the suction line coming right at the closest port out of the suction line coming right out of the evaporator. So at supermarkets, there's always a suction port right there, the evaporator case. If you're dealing with a small unit, you're probably going to have to gauge up to the compressor, and then you're going to have to add a couple PSI for your heat pickup, and your manufacturers can tell you what that is. So, but when you guys are checking superheat on a small unit that's like a self-contained, that's the way you're going to have to do it, because there's usually not a port right there at the evaporator. Okay. When you're checking superheat on a supermarket, it's right there on the outlet side of the suction line, right where the TXV is usually right there going in. The suction line's right there coming out, bolts mounted to the suction line. Okay. You're going to want to go on that port, and you're going to want to come 6 inches off the outlet, throw your clamp on there. Okay. What you're going to do is you're going to look at what your gauges are telling you, and then you're going to take your clamp temperature. That's one temperature. And then you're going to take your pressure and convert it to temperature. Okay. And you should see the differential there. So the difference in the temperature is your superheat. Okay. If it's too low, you're still too saturated. Okay. If your superheat's really close, if you have it running like a 2 degree superheat or a 4 degree superheat, depending on the system, you might be not boiling off enough inside the evaporator, and you're sending too much liquid back to the compressor. Okay. Now, evaporator superheat and compressor superheat are two different, it's the same concept, but it's two different readings. Okay. So what evaporator superheat is telling me is how efficiently I'm saturating that coil and how much heat pickup I'm getting based on the manufacturer specifications of heat pickup at that coil. Okay. When I'm dealing with compressor superheat, that's telling me how much liquid's coming back to my compressor, because refrigerant cool bodied compressors require cool gas, right? So that superheat setting matters to that compressor, because that's what's keeping that compressor alive. Okay. It's not the fan blowing across the body of the compressor that helps, but it's more of the refrigerant coming in that still has cooling heat pickup properties, and it's picking up heat from the internal of the compressor. So it's causing it to help cool the body of the compressor, keep it running for long periods of time. Okay. So that's why evaporator superheat matters for the efficiency of the case. Compressor superheat matters for the life and the life of the compressor. to sustain that compressor. Because if you go to any compressor class, they're going to tell you the one thing that keeps compressors alive is cool gas. Okay. Convert pressure to temperature with a PT chart. If reading is obtained at the compressor, not at the evaporator line leaving, you may need to add a few pounds of pressure due to the pressure drop in the suction line. Just talked about that. Take a temperature reading at the leaving suction line of the evaporator. Compare both the saturated temperature and leaving suction line temperatures, subtracting one from the other. The difference is the amount of the refrigerant gas that has heated past the saturated temperature. I guarantee you guys have all seen this, haven't you? It used to be on the back of all of our PT charts. If you ever got a PT chart from Sporlan, this is the picture that's on it. Okay. So let me go back here. Sorry, I hit that too quick. So that's kind of what I was talking about. You have your TXV coming in your inlet side. So you've got your pressure, you have your pressure stubby. You can do stubbies, or if you're on a market, I'm okay with you using charging hoses. I like stubbies. They're nice. They're easy. You can carry them everywhere. If you got a pair of Bluetooth gauges, Bluetooth's nice. Thing about Bluetooth gauges is you can hook up to that, and you can hook up to your clamp up to the pipe, and you can tell the thing what the refrigerant. You can tell the app what the refrigerant is, and it'll tell you what the superheat's supposed to be. Yeah. So, but if you don't have that stuff, like all you guys should have a PT chart somewhere in your truck. If not, you have an app on your phone. There's like 10 of them out there that are PT charts for any refrigerant you're dealing with. Does this make sense?
Yeah.
So, guys, like this is super important. This needs to be done quite often. So you guys, when you guys are running into problems, or we've been back and you know it's the second or third call and you're doing a health check, good diagnostics is doing a quick check with these. So the problem that I have with it is like I can't tell you how many times I'm looking at a system that holds like it's a critical charge, and guys grab us market guys grab our big 6-foot hoses and then we hook up to it. So that's going to cause you more work than it's worth. So you want to do a quick check down, check your superheat, make sure you're feeding properly. You know, you've gone through all the TECH and you're just finishing up with your superheat and subcooling. So, and then, I promise you, if you follow this and you know what you're doing, you drive away from every job feeling a lot better that you gave it a good, solid diagnostic check. Okay. And this is the time of year where you have the time to do this. So be disciplined in following it.
So with PT charge, whatever, don't you add like 30 degrees to the temperature, actual temperature, to see like what?
No, that's condensing. So what you're talking about is anytime you're doing condensing and you have gauged, it's ambient plus 30. So if it's 70 degrees outside, you're going to actually want your pressures to read more. If you converted that pressure to a temperature, you're going to be looking at more like 100 degrees. So anytime you're looking at condensing, that 30 you're talking about, that's how you check proper condensing. Ambient, whatever the outside temperature is, plus 30. Okay. Gauge up to a outlet suction straighter port. So let's talk about the superheat steps. We've talked about it. You're going to gauge up. First, you're going to take your stubbies and you're going to gauge up to the port. Second, you're going to take your amp. You're going to take your temp clamp. If you guys don't have a temp clamp, buy one today. Because if you want to try this out, I don't want to see somebody take a Velcro strap and strap a K thermometer to it. It just doesn't give you a good enough reading to really calibrate. This is a finite adjustment. It takes a lot of time and it takes finesse. And if you guys are going to do this stuff, like you need to make sure you have the right tools to do it. So using your PT chart to convert the pressure to temperature, or if you have the app or if you have it on your phone, I don't care how you guys do it, but you need to understand converting that pressure to temperature, looking for the difference between your temperature and your pressure. Your pressure is going to be lower than your temperature. Okay. So if your pressure's at X and your temperature is at 6 degrees warmer after you convert, that superheat. You're checking the vapors, the refrigerant's boiling and it's past the point of vaporization. And that's what superheat is. We're heating it past its boiling point. It's picking up more heat after it's boiled off to a vapor. That's what superheat is. You will take your clamp temperature minus your converted refrigerant temperature, and the total will be your superheated vapor. So the superheat is high. What does it tell us? starving evaporator. So that could be a plug screen on a TXV. That could be an issue with the TXV, power head issue, non-condensables are causing it to ice up. So, I mean, there's a problem with your metering device. So if you're dealing with a cap tube, it could be a restriction in your cap tube, okay? Improperly adjusted TXV. What I will tell you guys about adjusting TXVs is, a lot of guys do it differently. I always start at factory setting. So if I'm going to get on the TXV, I don't want to try to go where I think it started from. I'll wind it in. So the problem with winding in a TXV is if you go too fast and too hard, you'll over torque it. So go in slowly, back it out 3 full turns, start from there. That's where factory setting is on a Sporlan, and then start adjusting superheat from there. Once you make that adjustment, you need to give it 4 to 5 minutes. The second thing too is we never go after a TXV until we're close to optimal temperature, operating temperature, within 5 degrees, okay? Don't ever go after a TXV until you get close to the temperature. So after you've done everything and you know that you've cleared any like plug screen or restriction, and you know that thing's feeding and you can hear it trying to throttle, but you're still not getting good superheat out of that, and you get that case down close to temp, but it's not quite where you want it, or it's not recovering fast enough, then once you get it to that point, now you're going to get on that TXV. Okay. If the superheat is low, what does that tell us? So if the superheat's too low, it's going to flood the system. So the one thing I will tell you this is, depending on the manufacturer and the type of evaporator you're dealing with, so you guys can look pretty much anything up you want on Google. If you can't find it on Google and you're not really good at using Google, then get a hold of RSD or somebody and have them run it down with you based off of what that manufacturer wants to run as superheat. So we had a lot of issues with the low profile coils in Maverick. It's because everybody was setting the superheats way too high. They actually want those superheat. They want you to flood that coil, meaning they want that superheat running at about 4 degrees, which is really low for like a beer cooler, but that's where they want it. So we had issues for a long time, a few years back, because everybody was setting them at 12 because it was a cooler. So there is a slide on here that's going to give us general rules of thumb. If you cannot find the manufacturer's setting, instead of just leaving it because you don't know, I would rather you follow the rule of thumb. At least we're getting somewhere in the range. I don't want you to walk away without doing some kind of calibration if you suspect that you need to calibrate the expansion valve. Okay. Standard superheat. Okay. Anytime you're dealing with a 4 to 6 degree superheat, we're trying to flood the coil. Ice machines are running a flooded coil. Okay. Low profiles are running a flooded coil. So what that means is they're dumping a bunch of liquid into that coil, and they're expecting it to boil off. So, okay. So when you flood the coil, it's very saturated. It's a lot of liquid with a little bit of vapor. Okay. Freezer's 6 to 8 degrees. Everybody's going to start jumping on and say, no, it's 4. It's whatever that customer wants. But what I'm saying is, if you don't know, then stick to 4 to 6 degrees. I'm going to tell you, at Costco's and Walmart's and stuff, they're running lower. They're running mostly 4s and sometimes a little bit colder. The reason for that being is that liquid dumps into a big, huge suction header and an accumulator and a suction filter before it ever gets to the body of the compressor. So you can saturate the tar out of that case and still not have liquid hit the compressor. Make sense? Because you got a lot of other areas where that refrigerant can boil off before it gets to the compressor. So they'll turn it way down to flood that coil and get it nice and cold and nice and efficient, with knowing that it's going to boil off in the header, or it's going to boil off in the suction filter, or it's going to boil off in the accumulator. So, and if you guys are on the back of a rack, you might see ice on the bell end of the compressor. Okay, that's fine. Just make sure that it doesn't get more than a third up the body of that compressor, because now you're coming in a little hard. Yeah, you're going to flood that compressor. Okay, the best way to tell if you're still running too flooded is touch the oil pump. That'll tell you if you're coming in too hard on that compressor. Okay, if that rack's running and you see frost on the bell end of that compressor, go around to the front and touch the oil pump. The oil pump's cool to the touch. It's coming back way too hard. So then you need to go out and do some adjusting. Make sense? Okay, coolers 10 to 12 degrees. Again, this is a rule of thumb. So if you guys are running into like a medium temp application, you want to make sure that you're running that superheat at about 10 to 12 degrees. That's a good starting point. So the customer or the OEM manufacturer might have a different spec than that. So what I would tell you is like, these are good rules of thumb to get you in the range, but you might, like we saw with those low profile coils in the Mavericks, is we need to run them down more like a freezer. Okay. Yep. The thing about what you need to do is when you guys turn it down that low, where's the next place you're going to check your superheat? At the compressor. Okay. That's going to tell you if you're coming back too hard. On any single systems, I don't want to see that lower than 20. Okay. So the same way you're going to gauge up that compressor, you're going to put your gauge on the king valve. You're going to go 6 inches off that and you're going to put the clamp on. Okay. You don't want to see lower than 20. If you drop them below 20, you're coming back too rich. So, okay, on a single system. I'm not talking rack system. I got all the rack guys going, wait, I've seen them at 18. Yeah, I know. I'm not talking rack systems. I'm talking single systems, okay, or self-contains, right? Air conditioners do not use superheat as a measurement. AC manufacturers use subcooling for a measurement. We talked about that. So when a superheat, okay, it's when the case is within 5 degrees of its satisfactory conditions or optimal running temperatures. When checking compressor superheat, you're going to gauge up to your suction king valve port or process tube. So you guys all know what the process tube is, right? On the can compressors, you know that little Schrader port that sticks up that you can gauge up to on the compressor? That's your point if you don't have a king valve on the compressor. So on your smaller compressors, that's your crankcase pressure. That's going to tell you what your suction pressure is right there, the compressor. Using a PT chart, you'll then take the pressure and convert it to temperature. If you're using a blended refrigerant, you can use a dew point measurement on your chart. So remember the difference between dew and bubble. Bubble is going to be subcooling. Dew is going to be superheat. Okay. So if you guys are dealing with a 3-component or a 4-component, and I know there's even higher component blends now. I think I heard 448 was a 6-component. So 6 different components in that refrigerant. That's why the glide's so wide. When you guys are dealing with a blended refrigerant, you're going to have a glide. So you're going to have to make sure you're looking at the right value on that PT chart of what stage the refrigerant's in. Okay. That's why the glide matters. If you're looking at bubble, when you're doing superheat, you're going to be wrong. If you're looking at dew, because sometimes you're dealing with anywhere from a 6 degree to, I've seen it as high as 11 degrees on your glide. So obviously if you're dealing with an 11 degree glide, that's like a full state superheat setting temperature, right? You could be anywhere from a 9 to a 20 degree superheat if you're not looking at the right. So if you're at 20 degrees superheat, because you're checking the wrong, the wrong value at the wrong stage of the refrigerant, well, you're gonna, not only are you not going to capture enough refrigerant, but you're going to overheat the compressor. Because if your superheat's too high at the coil, you're not going to get enough cool gas back to the compressor. You're going to overheat it. You're going to take out that compressor. So it's, again, we're dealing with finite adjustments here. Too little, overheat, too much, you're going to flood it. So you got to make sure you're setting those properly. Taking the clamp measurements and subtracting the gauge temp will give you your compressor superheat. So how many of you guys do this when you do startups? How many of you guys change your contactor, change your filter dryer, check your compression ratios, and check your superheat at your compressor before you walk away? Don't lie to me.
That's what I said.
You should be doing that on startup. You just replaced anywhere from a $600 to a $10,000 component, depending on the application. Don't you think it's important to the customer that you calibrate that component? So,
When, like, if we did a evaporator and condenser change out, but not just the compressor.
you should do it. You should do it anytime you're changing major components. You should do an H. Yeah, you should go through a full diagnosis. You just changed conditions of that. So you may have done some repiping. You may have not flown nitrogen when you were welding. You may have, there's all kinds of things that happen during that installation. You should pull it down to temp. And when you get to temp, you should throw your gauges first at the evaporator, make sure your valve's feeding, your superheat's good, and then finish up at the compressor. And if you just do a compressor, you should check the compressor. because I can't tell you how many times it's like the third or fourth compressor. I'm like, has anybody checked, like, if it's running good? Like, what's our compression ratios? What's our superheat? And then 9 times out of 10, I go, oh, I'll check that this time. Okay. Let's do that, because now something's taking it out. So compressor superheat indications. What superheats are we shooting for on the compressor? Here's your ranges, guys. And I always say no lower than 20 on anything, because that's when you're really coming back hard, okay? Especially on single systems. So low temp, 20 to 25, no higher than 30. Lower than 20 is flooding the compressor. So, and again, all the rack guys are going to say, I've seen them run as low as 18 or 16. Okay, yeah, I get it, because you have a bunch of fudge factor on that rack to be able to do that. But single systems don't have those kind of components. So we want to see 20 at the compressor. Okay?
That's for HVAC.
That's for low temp. So that's freezers.
Oh,
So medium temp, this is coolers. Okay? Medium temp, 20 to 30, no higher than 35. So this is optimal running. Sometimes you'll see a little bit more. Sometimes you'll, just depending on conditions, depending on piping, right? So sometimes we'll see a little bit higher conditions, but, you know, again, we want to shoot for, we got to have something to shoot for. So this is what I want us to shoot for. So high temp 30 to 35, no higher than 40. If you guys are getting over 40, and this is not for HVAC compressors. You guys have heard of high temp and low temp application compressors. The reason why there's different applications is because there's different components. The windings are coated differently. The metals are different in the reeds and stuff. High temp compressors, AC compressors, are meant to handle a lot more superheat. Okay? So just so you know, that's why when you guys see on your little invoice, when you buy compressors, it says low temp, medium temp, high temp. It's because they're not all built equally. So they're built to the application. Okay? So you need to understand is like you need to take care of that. That's why, you know, there's a lot of times I'll use high temp applications and low temp compressors, because high temp compressors sometimes are a little bit more robust. So when you're dealing with like can compressors and scroll compressors, so on a high temp application. So you'll see high temp application compressors used in a low temp setting, but like it's just what the engineer decided to do with it. Okay, but you need to understand that's the variations. Is there's those internal components are, there's changes that have been made for the application. Okay, and that's why when we're doing HVAC, we don't want to look at superheat, because you're probably going to be over 40 a lot of times. Somebody have something to say?
I had a question.
Yeah.
What state does the system need to be in when you check the superheat on the compressor?
What state?
Yeah, do you need to be close to temp as same as?
Oh yeah, anytime, because what the temp's telling us is how the valve's feeding. Because when you get down to temp, if your valve's adjusted correctly, that's how it's throttling back and forth. So it's hard to take a superheat reading, because the valve, the TXV, as it modulates, is going to allow more liquid through or restrict or throttle back. So and that's gonna change how it's affecting your compressor. Plus, if the coil is warm, it's going to be higher because it's rejecting a lot. It's picking up a lot more heat while it's trying to get it down to cooling pressure. So it's flooding that coil really hard, right? So anytime you guys are charging or checking superheat, don't finish until that valve's at optimal condition, especially on smaller systems. A lot of systems get overcharged because we keep dumping because we think it's empty because the sight glass keeps flashing. The sight glass is flashing because that valve is wide open. Okay, and as that valve throttles back, it starts to hold back more liquid refrigerant, and then the sight glass clears. So let's make sure that when we're charging or when we're dialing in superheats, we're always, you know, topping off charges and stuff. We make sure that we check those charges when we're close to optimal running conditions, within 5 degrees. Okay, does that make sense?
Yeah, that's
okay.
Thank you.
Yeah, you bet. So high superheat, improper piping. Evaporator coil not feeding properly, low on charge, excessive heat pickup from the evaporator to the compressor, subcooler failed. Okay. Low superheat, flooding, overfeeding TXV, iced up evaporator, dirty or restricted evaporator, fan motor has failed, subcooler is set too low, heat exchanger has ruptured. Okay. We've seen all of these conditions. So what is happening anytime you have high superheat is you're either not condensing or you're picking up so much heat that you don't have enough heat pickup property to absorb the heat in the compressor. So what happens is it cycles, is the compressor gets hotter and hotter and hotter and hotter because we're not absorbing the heat through the cycles, and then it overheats the compressor. That's why it's important to superheat. If we're flooding, compressors compress gas or vapor. They do not compress liquid. So they don't like it. So as soon as you take a liquid and you draw back the cylinder a couple times, you start snapping metal. So either on the valve plate or on the wrist pin or on the rod or on the, it just starts to wreak havoc on the compressor. So what you guys need to understand is there's a lot of metals and bimetals built in these compressors. If you guys run into an overheating situation, I mean, I'd say by raise of hands, but half of you guys are online. But I mean, how many times have we gone out and we taken a overheating situation out of play, and then 2 days later we're changing the compressor, right? So we need to make sure that if we have an overheating situation, we need to note on our service trade ticket may have caused damage to compressor. So, because it does almost every time. If you overheat a compressor, internal damage has happened. As soon as you start to cool it back down and it starts to pump properly, it might work while you're there. But, a lot of times, I don't know, I'm not even going to give a percentage, but a lot of times I would end up going back and changing the compressor in a couple of days because it went down again.
Would it help to do an amp draw at all or no?
It just doesn't show up when you're there. It can run and cycle on and off, but without fail, like the next day or a couple hours later or a couple days later, the valve plate fails and the valves bust or something goes wrong. So when you overheat, you break down oil. So, and you heat up those metals and bimetals in that compressor, you cause them to be brittle. And then when you recool them down, it looks like it runs, but remember how many times that cylinder is slamming against that valve plate every minute of every day. It doesn't take much to snap that valve. So just make sure you guys are noting and protecting yourself. Little CYA note here is like, if you've overheated, if the condenser's been plugged or you had an overheating situation on a compressor, always note on the ticket, may have caused internal damage to compressor. Whether you think it has or not, just note it, because without fail, it's gonna come back to bite us. Subcooling, we talked about. So gauge up to the closest point of the liquid drain leg, outlet of the condenser. Use the PT chart to convert your pressure temperature. If you were using a blended refrigerant with temperature glide, you will use the bubble point. So remember, dew and bubble, okay? Just remember liquid is going to be bubble, dew is going to be vapor. Makes sense? Or saturated. So clamp your temperature clamp 6 inches away from where the liquid drain leg leaves the condenser. Take the clamp temperature minus the gauge temperature, and that will give you your subcooling. Subcooling targets. Most manufacturers have targeted a subcooling of 12 to 15 degrees. Again, consult the OEM. Google it. Talk to them. It may be different. This is just, again, I'm just trying to hit the range of where we see it most of the time to give you guys a starting point. They also need to be taken when the system is within 10 degrees of satisfactory operating conditions. High subcooling is from an incomplete condensing process. This is caused by flash gas. The cause of the symptom is low on charge, dirty coil, inefficient condensing fan, or malfunctioning head pressure control, headmaster. Okay. Is there any other questions? We covered a lot. So
on the thing I was talking about earlier where the evaporator had a bunch of
frost, yeah.
One thing I did notice when we got it defrosted and started up that the TXV was screaming a little.
Yeah.
So
anytime you guys start up a TXV from a warm condition, it's going to scream because it's throttled all the way back and it's wide open and it's just trying to saturate as fast as it can because that bulb's warm. When the bulb's warm, the diaphragm is pushing down on the expansion valve and it's opening up and the pressure's dropped because the compressor's drawing pressure from the backside of the evaporator. So the pressure's dropped, saying I'm ready to, you have a differential across the liquid of the evaporator because there's two closing. There's the evaporator pressure. So, and there's the spring pressure in the valve, the setting, and there's one opening. It's the element, the power head is pushing down on that push rod as opposing pressure. So as long as the evaporator has back pressure because the compressor's drawing on it, right? And as long as the bulb is warm, it's going to push that spring pressure opposed against that spring pressure, and it's going to send refrigerant into the coil as fast and as hard as it can. So when you start up a compressor, when it's warm, you should hear it taking off. You should hear that liquid just rolling into that evaporator hard. What you should hear when you start to get down to optimal temp is that valve start to throttle back. You should start to get it quieter and quieter. And then if you get real close to the valve, you can hear it, you know, opening and throttling, opening and shutting, like at minute adjustments, trying to obtain that superheat that you just set it to. Okay. The other thing too is like, if it didn't just come out of a defrost and you're walking by in a supermarket and you hear a case going, probably low on charge, and that valve is wide open, starving, it's too warm, or you got a bad expansion valve. So if you hear that noise on a case that looks like it's trying to run, that's when you're going to look into it. Because if a valve's throttled wide open and it's not coming out of a warm condition, then you might have an issue. You might be low on charge. We can hear valves starving. Like if you walk by Market Techs, we hate that noise because we're like, oh, we're going to be here a while finding a leak. So if I walk by a case and I can hear it like wide open, I'm like, oh, crap. It's like two worst noises: starving valve, quiet machine room.
Yeah. Yeah.
In a supermarket. So, okay.
Sweet.
Guys, that H is super important. Like, and if you don't know what you're doing, but you want to do something about it, you want to learn it, like make sure you consult your manager or your lead technician on how to properly set, because when you're getting into those finite calibrations, you can do a lot of good for the system or you can do a lot of damage really easily. So, and I'm not saying that to scare you. I'm just saying let's make sure we do the right thing and not be afraid to ask the question if we have the question. So, because we've all been there. We've all had to ask that question, is like, where should this be? How do I set it? Is counterclockwise the right way to go, or is clockwise the right way to go? Like, how do I increase the superheat, decrease the superheat? For years, I couldn't remember. Is it open? Is it shut? You know, which way am I supposed to go? So I would call my manager and I would say, hey, you know, remind me again. And he'd laugh a little bit and then he'd tell me. And I'm like, okay. And I'd write it down in my notepad and I'd forget. So it's okay. But I'd rather you ask the questions and let's just make sure we're doing it right. So thanks, guys. Have a good day.
Thanks, buddy.
Thanks, Jim.